Here. Welcome to Ethics of AI, Day 2. I hope you all enjoyed it yesterday. Today, we're gradually transitioning from the shorter term to longer term issues and thinking about the ethics of AI. Although I think, as you'll see, some of the issues that come up today are still relevant at both levels. The session this morning is a mega session on artificial intelligence and human values, especially thinking about the way to which certain kinds of values and goals may want to affect the way that we design AI in order to have outcomes that meet with human values. This has been a major research program among both philosophers and AI researchers thinking about AI. I mean, the key idea is that as AI becomes increasingly powerful, then its impact on the world is going to be to some very significant part determined by what its goals are. And in order to make sure that impact is one that aligns with our human values, maybe we ought to think about building in something like those values into an AI system. Now, this is a very rich subject. It raises all kinds of technical issues on the AI research side. It raises all kinds of formal issues. It also raises some very rich philosophical issues for, does this whole approach embody certain substantive philosophical assumptions about the way in which, for example, value interacts with intelligence and rationality. So to this end, we've got this session with 5 talks this morning approaching that issue from a number of different directions. The first 2 speakers are going to come, broadly speaking, from the area of AI research. The third talk is going to bring in physics and psychology perspective for thinking about the issue of value. And the fourth and the fifth talks are, I guess you could see as offering a kind of philosophical response and analysis to some of these issues. So we'll have 5 20-minute talks, each followed by a 10-minute Q&A. Maybe we'll take a very brief moment to stretch our legs after the third talk. And then the thought is at the end, we may have, hopefully we'll have time for a substantial panel discussion among the group of the issues. But for the first talk, it's a pleasure to have Stuart Russell here. Stuart, of course, is a major figure in artificial intelligence, done all kinds of important work over the years, and he's the co-author of what's been the canonical textbook in the field for some years now. He's also been very much ahead of the curve in thinking about AI impact and the various ethical and social issues that arise. He's now setting up a major center at Berkeley for thinking about precisely these issues, and he's played a very big role, I think, in drawing the attention of AI researchers to these issues. And his talk today is on Provably beneficial AI. So please welcome Stuart Russell.
Thank you very much, David. So I'll just get right into it. I think we'll take this as a given. I don't want to argue about this, although one can argue with it, that we will have AI systems that, in the same sense that AlphaGo makes better decisions than we do on the Go board, that AI systems will make better decisions than we do on the world board. And this is a good thing because everything that we have, that we hold valuable as part of our civilization, is the result of our intelligence. And so if we have access to a significantly larger source of intelligence, if we use it wisely, then it cannot help but be a step change in civilization, or some people have called it the biggest event in the history of the human race. And then the downside, I don't want to be alarmist or anything, but there's a few downsides, killer robots being one of them, the end of employment being another, and the end of the world being the third. In some order. So I'm going to talk about this third one. Why are people worried about this? Well, if you just think about it, right, we're going to create things that are much smarter than we are. right? And that just gives you a sense of unease. Turing expressed that unease even before the field was named artificial intelligence. He said that, in the best case, they'll keep us as pets. So this is not a new concern. If you ask these gorillas, here they are having a meeting to discuss it, were your ancestors wise to create this human race, these more intelligent beings than us? I think by now they'd say, no, it wasn't a good idea. Okay, so why specifically? We're not creating a new species, and these are things that we design. So perhaps it's a different situation. It's also perhaps different from a superior alien civilization landing on Earth. So those analogies are not exactly persuasive. So what's really wrong? So even though we will design these systems, the problem is that they could be extremely good at achieving anything, and in particular, things that we don't want. And there is no real discipline that exists right now of figuring out what we want and making sure that that's what the machines are actually achieving. So all the fields that deal with rational decision-making assume that the objective is exogenous, that someone else is going to come along and plug it in, and then the machinery, whether it's the AI system or the econometric optimization or whatever it might be, the machinery is going to figure out how to achieve that objective and maximize that utility function. And this point was made by Norbert Wiener in a very nice paper from 1960. And I recommend reading that paper if you have the chance. So he says, if we use to achieve our purposes a mechanical agency with whose operation we cannot interfere effectively, we had better be quite sure that the purpose put into the machine is the purpose which we really desire. And that sort of says it right there. And you could say that this basic idea goes back a lot further. So King Midas put the purpose into the machine, so to speak, when he asked that everything turn into gold that he touches. And then it was too late. He realized that his food and his drink and his relatives were turning to gold, and he died of misery and starvation. And there was this problem of a superior agency carrying out the wishes that you state. Recently, Steve Omohundro, 15 years or so ago, Steve Omohundro pointed out that there's even a worse problem, or something that compounds that problem, that no matter what the objective you put in, it's very hard for a machine to achieve that objective if it's dead. And therefore, the machine will attempt to preserve its own existence, even if you don't put that in as an objective. And this has been discussed extensively yesterday as well. And it will also improve its chances of success by acquiring as much resources as it can. And so if you have those tendencies combined with an objective that is not quite the one that you want, then you're setting up a kind of a chess match or a go match between the machine and the human race, and that doesn't necessarily go too well. And so this is the basis of the concern, or one of the bases for the concern. There are others, such as misuse, which I'm not going to address today, but that's also a serious concern. So there's a number of arguments people have put forward why we shouldn't pay attention. In fact, there's so many that I can't go through even half of them. And I could just, for those of you who have doubts that this is even worth studying, please come up with a more serious argument than the ones that people have come up with so far. So I'll just give you a few examples. So you often see people within the AI research community having said all along that we're going to achieve superintelligent AI. As soon as you point out that might be a bad idea, that, oh, it's never going to actually happen, right? We're not really going to produce superintelligent AI. And I just like to tell a little story about this gentleman, who's Lord Rutherford, who was the most famous nuclear physicist of his time. And on September 11th, 1933, he repeated something that he had been saying in many venues in many ways, that anyone who looks for a source of power in the transformation of the atoms is talking moonshine. Right? And his position was that we would never be able to figure out how to extract the energy that they knew was there in atoms, because they already knew about mass defect and E equals mc squared. But even Einstein was convinced that it was basically impossible to get that energy out. And then on, this is Leo Szilard, by the way, on September 12th, 1933, he figured out how to do it. So you have to be a little bit careful when you say that something is never going to happen. So, some people say, well, it'll happen. It's so far off that we don't need to worry about it. And you could say the same thing about, the catastrophic effects of global warming. They're sort of off towards the end of the century, so let's not worry about it. Let's just keep on doing what we're doing. But if you, for example, detected a large asteroid that was going to crash into the Earth in 50 years' time, you wouldn't say, oh, it's so far off we don't need to worry about it, right? You'd say, well, it might take 50 years to figure out how to divert it or destroy it or whatever, so let's start thinking about it now. And just to add to that, this is not an accidental event. This is something that we, the world, are driving towards, right? We are using tens of thousands of highly trained scientists, billions of dollars, to move in this direction. So it seems worthwhile to think about what happens when you get there. Okay, so I'm going to skip over a lot of the rest of these arguments. Right? So one of my favorites is well-known AI people say, oh, there's really nothing to worry about. We can just switch it off, right? As if a super intelligent machine couldn't think of that one, And so these arguments are symptomatic of a denial syndrome that is worrying, actually, because these are smart people and they're producing arguments that don't hold water for very long at all. And probably one of the most insidious ones, actually, which in the most recent report from the AI 100 study at Stanford, so this is a large body of distinguished AI researchers saying, well, there might be risks, but don't mention them, because if you mention them, that might damage research on risk, right? Which is just completely bizarre. And it hasn't been a good strategy in the past. It didn't do the nuclear industry much good to pretend that meltdowns couldn't happen and that nuclear waste did not need to be disposed of, and so on and so forth. And essentially the lack of honesty and which caused, I think, a lack of internal research and development and attention paid to risk led to the effective demise of the entire nuclear industry. So there are no good examples of industries that succeed in the long run by pretending that something that is real isn't real. As David mentioned, we just started a new center called, somewhat rudely perhaps, the Center for Human Compatible AI, as if the rest of the field isn't human compatible. But the title serves to just remind us that the whole point of AI is not to create intelligence for its own sake, although that's a really cool thing to work on, but actually to benefit the human race, and we ought to make sure that happens. And to do that, we have this goal of building AI systems that are provably beneficial. And this is, in some sense, a deliberate oxymoron, because beneficial is a very touchy-feely, vague term, and provably is sort of the opposite. So how do you put these things together? So I have there's three principles that have been helpful so far in our research. So the first one, I think we can all agree with, is that the robot's objective is to maximize values for humans. And in particular, it has no objectives of its own. It has no self-preservation. It pays no attention to its own, even its own monetary value, because it's only the human that cares about the monetary value of the robot. And so you really care just about the maximization of human values. The second principle is that the robot doesn't know what they are. This turns out to be very important. And then the third principle is that there is information about what those values are in the behavior of humans, in what economists call the revealed preferences of human beings. This term value alignment is used in the general AI safety area. It means how do we get the objectives of the robot lined up in the way that I just described with those of human beings. And so one technique that was actually invented for entirely other purposes, actually to try to understand the motor behavior of cockroaches, is called inverse reinforcement learning. And it's the opposite of reinforcement learning. So reinforcement learning, you are given a reward signal, and then you try to adapt your own behavior to get more of that reward, to optimize your long-term sum of rewards. And inverse reinforcement learning is the other way around. You're observing a behavior, and you're trying to figure out what is the reward function that this behavior is optimizing. So if the machine is observing the human and the choices that the human makes, that allows the machine to gradually understand the value system that the human's behavior is driven by. And it turns out, just in the same way that when I want to define a task for a machine, then defining the reward function is a very succinct way of defining what the task is, as opposed to, for example, describing all the action sequences that the machine should take under all circumstances, which is usually not a very concise way of describing it. In the other direction, as an explanation of the behavior, the reward function can be a very concise explanation and hence very predictive. And so this can be a good way of learning, of the robot learning how to behave well by first of all learning what the reward function should be. And this technique has been used to program helicopters to do aerobatics and various other kinds of tasks. It's being considered for use in self-driving cars so that the car drives in a style that you are comfortable with and so on. So we actually need a slightly different version of this. So in inverse reinforcement learning, usually the robot is observing and learning this objective, then adopts that objective as its own. We don't quite want that because if I'm drinking coffee, I don't want the robot to learn that it should drink coffee. That's not quite what we want. We want the robot to learn to make coffee for me rather than want the coffee. So we have a slightly more complicated version called cooperative inverse reinforcement learning, which is, in the simple form, a two-player game. So there's a human and a robot. And so the human knows, in a sense, the value function, in that the human can act according to it, but may not be able to explicate it in a form that could be directly programmed into the robot. And we can allow for the human to be not perfectly rational. They can make mistakes and so on. And then the robot doesn't know what this value function is, but its job is to optimize it. And when you look at the solutions to this two-player game, you find that they exhibit the properties that you would hope, that the robot now has an incentive to ask questions of the human and to explore, but do things cautiously because it doesn't want to do things that the human would be unhappy with. And the human has an incentive to teach the robot. And these fall out directly as solutions of this two-player game. We're not programming in teaching as a behavior. It just is an automatic consequence of the definition of the problem. And in fact, the human does not display the same optimal behavior that they would if the robot wasn't there. So in fact, that means that the inverse reinforcement learning formulation, where the robot is assumed to be observing optimal behavior by a human, is actually an extreme special case where it's sort of looking through a two-way mirror and the human doesn't even know they're being observed. But in general, the human will not behave optimally and will, for example, demonstrate, if it's, let's say, a surgeon, right, will not just sew up the patient, but will demonstrate carefully the steps of sewing up and maybe even give a commentary and so on. So, the things you want to have happen will happen in this scenario. So let me just give one simple illustration in the context of what's called the off-switch problem. So as Steve Omohundro pointed out, if you have an objective and the robot understands that it can't achieve that objective if it's dead, so the catchphrase of this talk is you can't fetch the coffee if you're dead. So in that circumstance, the robot would seem to want to disable its own off switch, because if there's a possibility that it might get switched off and therefore fail to get the coffee, it seems like it's rational for the robot to disable the off switch so that that can't happen. And we don't like this idea, right? This is precisely the beginning of the robot apocalypse. And how can we avoid that? So the answer is don't give the robot an objective. Really don't give the robot a precise objective. The robot should be uncertain about what the true human objective is. It might know that all things being equal, getting coffee is better than not getting coffee. But the all things being equal covers a lot of other attributes, like whether or not it's okay to assassinate other people who are in line for coffee in case they run out of coffee before you get to the front of the line. Is it okay to disable your off switch and so on? And obviously, there can be uncertainty about the objective as a whole. And the nice thing about that uncertainty is that the robot now reasons to itself, okay, well, I'm trying to make the human happy. I'm not quite sure how to do that. And my actions might be such that the human could understand that I'm going about this the wrong way, in which case the human will switch me off. But when you have uncertainty about the objective, that's a good thing, because the human is going to switch you off if switching off the robot is a better choice for the human. And since the robot cares about making a better choice for the human, then the robot in that situation would be happy to be switched off. It won't switch itself off because it doesn't believe that what it's doing is necessarily bad for the human, but it knows that the human knows better and will switch it off if that provides an advantage to the human. So you can prove that under fairly general circumstances, if you set things up this way, it's in the robot's interest to be switched off. Thank you. Okay, so this is right. This is a. This, I think, is a fairly general point. I mean, the theorems and scenarios we've defined so far are quite, simple, specialized pedagogical examples to illustrate the basic point. But I think uncertainty in objectives is actually a much more important and general issue that we've largely ignored. I mean, in AI, we spent the first 30 years of the field saying there is no uncertainty, period. Right, that we have symbolic logical definitions, we have definite transition models, we have perfectly observable environments like chess, and then sometime in the early 80s, we said, okay, there is uncertainty. Our sensors are not perfect, and we don't exactly know what's going to happen. So there was a whole sort of revolution in AI. But even throughout that revolution, the idea that the objective itself was uncertain was completely ignored. It's just not even thought about, and which is bizarre, really. And there is actually a technical reason why you might have ignored it, but I don't think this was the reason why it was ignored, which is that in a standard decision problem like a Markov decision process, uncertainty in the objective is actually completely irrelevant because you can just integrate over it and you behave exactly like the agent that has the definite objective, which is the expectation of your uncertain objective. So what's the difference? Okay, it's maybe more than 1 minute, sorry. So what's the difference? The difference is that in reality, the environment can provide more information about the objective. If it doesn't, then it really doesn't matter. The uncertainty can be integrated out. But if it does, then it really does matter, and you get very different behaviors than you can get from any agent that has a definite objective. And so observable human actions are a source of information about what the true objective is. You might also say, well, what about reward signals? What about the standard reinforcement learning setting where a reward signal is provided? And that could provide more information about the objective. Well, I actually think that this is an incorrect mathematical framework. I've come to this conclusion reluctantly because I think reinforcement learning is great, but I don't think the reward signal is a reward. I think the reward signal should be viewed as information about what the true reward is. Okay, and if you think about it, right, if your objective is to maximize human values, then your reward is in some senses in heaven, right? That the human is happy with what's going on. And the human can't give you a reward, right? All it can do is tell you that the human is possibly happy with what's going on. And if you formulate it this way, if the reward signal is just information and not an actual reward, then the wire-heading problem, which is the problem that a reward-seeking agent will take over the mechanism that provides rewards and then feed itself as much reward as it can possibly generate, that problem goes away, because if you take over the human who is providing the reward signal and force them to give you rewards, you're not actually gaining any information whatsoever about what the true human reward function is. And so, in fact, it's deleterious to your objective, which is to make the human actually happy, right, rather than make the human supply you with reward signals. And so this perspective, I think, maybe resolves some of the concerns that people have had about wireheading and those negative consequences of reinforcement learning setups. So what we're trying to get then is a theorem like this, right, that as long as the human can be viewed as even slightly better than random in choosing their actions to optimize their own objectives, then a robot observing that human will be a net benefit compared to not existing. And we can show this theorem in these simple settings, and we hope to be able to generalize this to more interesting things. Very quickly, if we take this seriously, right, we get outside of toy worlds and we say, all right, let's think about 20, 30 years where we really do want to figure out the human value function so that by the time we have powerful AI systems, they can actually understand what we want and do things right without everything having to be spelled out in enormous detail. There's a massive amount of evidence about human behavior. Pretty much everything we've ever written is about people doing things and other people being upset about it. And so all of this provides evidence for what our value function is. So that's a good thing. Another good thing is that we will have to solve this problem not in the long term, but actually in the short term. If you have a personal digital assistant, which is now a very rapidly growing sector of the industry, you don't want your assistant and, let's say, Donald Trump's assistant to have the same objectives, right? That wouldn't work very well at all. And so your assistant has actually got to learn your preferences very quickly and book you into the right kind of hotels and put you on the right flights and refuse emails from the right people and so on and so forth. So we have to solve this problem pretty quickly. There's a very strong economic incentive, which I think explains in part the emergence of this partnership for AI. So just to give you another example, right, if the robot is in the house and has to feed the kids because you are late home from work and there's nothing in the fridge and the robot sees the cat, then you could have a problem, right? And that only has to happen once for the domestic robot industry to be wiped out for a decade. So there's this really strong incentive to get this problem right, to understand the nutritional value versus sentimental value trade-off. Unfortunately, right, here's the big problem, and I'm sure all of you social scientists know this already, that people are much more complicated than just straightforward, uniform utility optimizers. There are a lot of nasty people. We have very strong constraints on our computational architecture and capabilities, and we vary enormously, or possibly enormously, in our various preferences. And it's not even clear that even if we allow for the computational limitations of humans, that if we knew what those were, would it still be the case that we could model a human as having a value system but optimizing it in this very limited and inaccurate way? It's not even clear that that's true. But that's the working hypothesis for the time being. The other question, oh, I got these in the wrong order. So the other question is then, how do we not learn from Hitler's behavior? And this is a complicated thing, right? Obviously, if everyone behaved like Hitler, then all those Hitlers would be very unhappy, right? Because none of them would have world domination, and this would be a very unsuccessful group of humans. So there's a sort of lack of self-consistency in certain types of value functions that prefer domination of other people and are not happy when other people are happy, and so on and so forth. So I don't want to be in the business of dictating what the world value function should be, but we would like some way of doing better than just taking a sort of population average. Okay. So there's a lot of questions, and David will probably say, why don't we have the audience ask those questions? So fine, I'll just give you some prompts. So this is a big change, I think, in the way AI thinks about its goal, which has been, let's build intelligence, and then we'll plug in objectives and hope for the best. Instead, let's build systems that are provably beneficial for us, right? Not for ants or aliens, but for us. There's interesting questions about, well, where do human values come from in the first place? I used to think that it was sort of, all sort of derivative from the basic biological drives, but actually I think it's much more cultural and passed on by sort of built-in inverse reinforcement learning process that we come with. And we adopt the values that we use to explain the behavior of others around us. I'm going to stop now. Okay.
We got time for 1 or 2 questions. Ned and Eliezer, when you come up here and get set up. He's just turning them on.
Yeah, that's on. So how do you keep the robots from manipulating the human values? That would be a much better way of making sure the robot knows what those values are to make them be a certain way. Also, you could produce values that are easier to satisfy.
Yes, I mean that's true. The robot could do brain surgery and change the values, but in the model we have, actually the human values are assumed to be fixed, so that wouldn't actually work.
But they're not fixed.
Right. I agree with that as a general point, but one step at a time.
Here.
So you say that these AIs would observe humans in order to determine what the value function is. But you answer your question about how we prevent the off-switch problem by having the AIs assume that. My question is, how will AIs account for human mistakes while also maintaining that a human turning it off is in the best interest for human values? So the robot could assume that the human is making a mistake when it tries to turn off the robot.
Yeah. So the model that's in the paper allows for the human to behave suboptimally, right? And there's a standard called the Boltzmann model, where the human picks an action, but with certain probability picks something suboptimal, and the probability of picking it drops off exponentially with how bad it is. And so in that model, you can show that the larger the irrationality of the human, the more of a buffer you need in the form of uncertainty about what the utility function is. But if your buffer is large enough, then there's still a positive incentive to allow yourself to be switched off. If the human is deliberately anti-rational, right? So on average, the human works against their own best interest. Then that really is a problem, right? Because then it doesn't make any sense to assume that the human is going to switch you off in order to benefit the human, because in fact this human will switch you off in order to hurt themselves. And what do you do with a human who acts to hurt themselves, who acts to hurt themselves, even though they don't want to?
Okay, thank you very much. Okay. Stuart, we desperately need your assistance down here to set up your laptop for Eliezer. In the meantime, I'll give a leisurely introduction for Eliezer. It's a pleasure to have Eliezer Yudkowsky as our next speaker. Eliezer is really a pioneer in these issues about safe, beneficial, and ethical AI. He's been working on this stuff since the 1990s, where I first came across his work on the singularity and friendly AI. On the web, he co-founded the Singularity Institute for Artificial Intelligence in the early 2000s, which is now spun off into 2 major institutes: the Machine Intelligence Research Institute and the